It turns out that studies have been done that show that if you know a musical instrument or you know how to sing, you'll be better at rational thinking. You'll be better at solving Physics 6a problems because, I don't know, but the relationship, you'll meet lots of, if you talk to other physical science people, mathematicians or physicists, you'll find that many of them know about music also, or appreciate music, and they know how to sing, or they know how to play the piano, or they know how to play a flute, or whatever, and guitar. And so there is this connection. So your homework is to memorize this song. You'll do better in this course if you memorize the song, I can guarantee you. And to get the song, you look up there on the top of the board, there's the URL to where you can get a copy of the lyrics and a copy of the score, and even an MP3 file made from a MIDI file for this song. So get that and memorize it, sing it in the shower, sing it to your roommate, practice it so you have it down cold, and you'll do better in this course. You'll get a higher grade on the final, you'll get a higher grade overall. So we'll sing it. One thing about this song is that there's a verse in the song about Newton's second law, which, as the verse says, is the central feature of the course, and you'll see from Stephanie's lecture today, as focuses on the angular form of Newton's second law. But I put up here on some words you'll see in your textbook or in conversations with other folks. The expression F equals ma. Well, the expression F equals ma is not the way Newton wrote it. Usually, when you write an equal sign when expressing a physics law, the cause is on the right of the equal sign, and the effect is on the left. So when you say F equals ma, well, the cause is not the acceleration. The cause is the force. So you should put the force on the right of the equal sign and the acceleration on the left. Also, when Newton wrote this, and by the way, in Newton's time, the word physics did not exist. His subject was called natural philosophy. So this is a course about describing the behavior of the natural world out there, the world of nature, not the world of tall buildings so much and human activity, but the world of nature in a certain way, using the language of mathematics. So natural philosophy is what Newton called it, and he wrote that about the momentum and the force, that the force gives rise to a change in the momentum, and the momentum can change either by the mass changing or by the velocity changing. The momentum is the mass times the velocity, as you know, or both of them at once, as in rocket motion, which gets hard to understand. It's not always the mass times just a constant mass. So usually there refers to that equation when the mass is constant. So that's about the verse in the song, and there's the angular version of it. You also put the torque on the right-hand side, and as Stephanie will talk about in your textbook, they don't get it right. So you can be smarter than the guys who wrote the textbook. This song is called It's Gravity with a capital G. It's gravity with a capital G makes the moon go around and around. It's gravity with a capital G makes the apples all fall down. Oh, capital G times M1 times M2 divided by R to the power of 2. It's gravity with a capital G makes the moon go around and around. Yes, yes. Now when I say yes, yes, that's your turn to sing the line, and all you do is just repeat the line that I just sang. So if I say, it's gravity with a capital G makes the moon go around and around. Yes, yes. It's gravity with a capital G makes the moon go around and around. Good. That happens with every verse, right? Okay. If you go for a ride and you collide, the momentum is conserved. You may die in a mess, but nevertheless the momentum is conserved. Now we all know that there may not be conservation of kinetic energy, but if you go for a ride and you collide, the momentum is conserved. Yes, yes, if you go for a ride and you collide, the momentum is conserved. Well, let's have some fun with the pendulum at the playground, swinging so free. You'll oscillate, it'll feel so great, get rid of anxiety. Now the time it takes for a cycle is 2 pi root L over G. Let's have some fun with the pendulum at the playground, swinging so free. Yes, yes, well, let's have some fun with the pendulum at the playground, swinging so free. There's a monkey in the tree right up there for all to see. And here comes a hunter with a gun. The hunter takes aim, that's the name of the game, shoots the gun directly at the monkey's bum. But the bullet and the monkey both fall with G, and they meet at the same point in space. So much to his surprise, the poor little monkey died. And the hunter, oh, let me tell you about the hunter. Much to the surprise of the hunter, there materialized upon the scene at the time of this dastardly deed a game warden, who immediately arrested the hunter, charged him with the wrongful taking of an endangered species, and hauled him into court, where he was tried by a jury of his peers, found guilty as charged, and sentenced by the judge to to 10 years of hard labor devoted to the restoration of the habitat for the endangered species of our planet. So, next time that you see a little monkey up in a tree, tell the hunter not to shoot his gun. Yes, yes. Next time that you see a little monkey up in a tree, tell the hunter not to shoot his gun. Well, the next thing that we saw was Newton's second law. This is the central feature of the course. With a mathematical flavor, it describes the behavior of a particle that is subject to a force. We say the change in the momentum of the particle will be an amount precisely equal to F dt, and we promise not to say F equals ma when we describe the central feature of the course. Yes, yes, we promise not to say F equals ma when we describe the central feature of the course. Now we're in the lecture hall with the super balls. What makes that little one fly so high? You drop them on the ground and they rebound and the little one flies up to the sky. Well, just conserve the momentum and also the energy. So when you're in the lecture hall with the super balls, you'll know what makes that little one fly so high. When you're in the lecture hall with the super balls, you'll know what makes that little one fly so high. Yes, yes. When you're in the lecture hall with the super balls, you'll know what makes that little one fly so high. Well, it's time to get the feel of the bicycle wheel and spin yourself right up to speed. Just apply a torque. Now that will take some work, but you'll get the angular velocity. And integrate the torque with respect to t, and you'll have the angular momentum. So it's time to get the feel of the bicycle wheel and spin yourself right up to speed. Yes, yes, it's time to get the feel of the bicycle wheel and spin yourself right up to speed. Now at the playground on the merry-go-round in the rotating reference frame, there are pseudo forces, two, of course, Coriolis and centrifugal by name. Toss a beat bag to your friend. Why does it go in a curve? At the playground in the merry-go-round in the rotating reference frame. Yes, yes, at the playground in the merry-go-round in the rotating reference frame. Alas, we had no time to deal with Einstein's theory of the special relativity. Your clock will run slow as if you decide to go on a trip at high velocity. And if at age 21 you should have a son and step aboard a spaceship for a star, well, when you return, you will learn that your son could be older than you are. Yes, yes. When you return, you will learn that your son could be older than you are. Yes, yes. So if the T with a capital G makes the move go around and around, it's gravity with a capital G makes the apples all fall down. It's capital G times M1 times M2 divided by R to the power of 2 is gravity with a capital G makes the moon go around and around. Yes, yes! Gravity with a capital G makes the moon go around and around. Okay. Got to memorize it. Memorize it. Memorize it.